This video is going to be on solving a 2x2 system using Cramer's rule. Recognize that the principles that we're going to talk about here can be used for solving a 3x3 system with Cramer's rule also. It's just this video is only going to be about a 2x2. So the idea is first recognize this is a simple two equation system. So you've probably already learned how to solve this by like substitution or elimination, something like that. This is simply another method that we could use to solve the same type of systems. We're going to use matrices. Basically what we're going to be doing is for both x and y, we are going to build two 2x2 matrices and find the determinants of them. So before we start doing that, there are two matrices I would want you to kind of see when you're looking at this system. The first matrix that I'd want you to see is what we would call a coefficient matrix. If you remember, a coefficient is a number in front of a variable, basically. So in the case of this system, I have an A and a C that are both meant to represent the coefficients in front of x. Alright, they're both the coefficients in front of x. I also have a B and a D that are meant to represent the coefficients in front of y. And so that would be our coefficient matrix, just simply A, B, C, D, all the numbers in front of the variables. The other matrix I would want you to see is what we would call our constant matrix. If you remember, constants are numbers that are just by themselves. They don't have any variables, which in this case would be the E and the F that are sitting on the ends of these equations. They don't have any variables. We're going to use these two to build our matrices that we actually use to solve for x and y. So let's say we decide we want to solve for x first. Our denominator, our bottom matrix, is simply going to be the coefficient matrix, nothing altered. So A, B, should use the colors though, A, B, C, D. Alright, that's your coefficient matrix, that's all it's going to be. In the numerator, what we're going to do is half of our matrix is going to be rewritten and half of it is going to be replaced, meaning we are going to replace one of the columns in our coefficient matrix with our constant matrix. The column we replace should be the variable that we are solving for, meaning since this is us solving for x, we want to replace the coefficients that went with x, which in this case would be A and C. So instead of AC, I will have a column that is EF. But I will repeat the y column of just BD. It's the same idea if we want to set up for y. So again, the denominator is simply going to be the same coefficient matrix that we are used to having. So no alterations, nothing changed. The numerator is going to have one of the columns replaced and one of the columns rewritten. The one that is replaced should be the one that represents the variable we are solving for. We are solving for y, so this time we should be replacing B and D as those were the y coefficients. So instead of B and D, we have E and F, and then we still go ahead and rewrite the A and the C. This would be how you set up a Cramer's rule, a system to solve for the Cramer's rule. So as an example here, let's look at this system of 3x minus 2y equals 10 and negative 6x plus y equals negative 7. So first, I want to make sure that everything is set up in order, right? Obviously these matrices, building these matrices only works if you've got both equations in the same order. So I do see x's, then y's equals my constants, so that all lines up and everything. If it had not lined up that way, I would need to rearrange the equations to make them line up in that form. Do recognize it's not really an option like it is with some other strategies. You want to make sure that you have these lined up correctly before you get going. Since this is lined up correctly, I want to go ahead and start, I probably want to determine what my coefficient and constant matrices are. So for coefficient, my matrix would be 3, -2, -6, 1. Reason for that being, we've got our x's right here. So there's my column for my x coefficients. And we've got our y's right here. And so here's my column for the y coefficients, right? And then our constant matrix would simply be 10, -7, representing the two constants that we have. Okay? So I like to start solving for x. So I'll start by building my two matrices for x. Remember that the denominator is literally just your coefficient matrix, not any other, not written any different, no changes. So we'd have 3, -2, -6, 1. That's all you gotta do. For the numerator, this is where we actually are going to adjust something, where we're going to replace one of our columns. Well, if we're solving for x, we want to be replacing the x column. The x column was 3, -6. So instead of 3, -6, we put 10, -7. We just repeat the -2, +1. And then we're going to want to find the determinants of both these matrices. So remember, you should have already watched the video on finding determinants. So the way you find a 2 by 2 determinant is taking your downhill diagonal minus your uphill diagonal. Meaning, in this case, our downhill diagonal would be 10 and 1, so 10 times 1 gives us 10. Our uphill diagonal would be -7 and -2, so -7 times -2 is +14. And we're supposed to take our downhill diagonal minus our uphill diagonal. So in other words, we are doing 10 minus 14, which would be -4. Looking at our matrix in our denominator, our downhill diagonal would be 3 times 1, which is 3, minus our uphill diagonal of -6 times -2, which would be +12. So 3 minus 12 gives us -9. -4 and -9 do not divide evenly. It is also not a fraction that can be reduced, but we do know that a negative divided by a negative is a positive, so we can at least say that x is equal to +4/9. Now, we would need to build our y fraction. So for y, our denominator should be exactly the same as it was for x, meaning I already know the denominator is going to be our coefficient matrix of 3, -2, -6, 1. Since I'm solving for y, I know that the column I will be replacing is the second column that represented the y's, so I can rewrite the 3 and -6. Remember that our constant matrix was 10, -7. And so 10 and -7 is what we'll be replacing our -2 and 1. I really don't need to solve out for the determinant of my denominator again. I've already proven that it's -9 right up here. So really I just need to find the determinant of the numerator matrix. Well, that would be a downhill diagonal of 3 times -7 to give us -21. And that would be minus our uphill diagonal of -6 times 10, which would be -60. So if we're taking -21 minus -60, effectively we're really taking -21 plus 60. Well, that would give us a +39, which is going to be divided by that -9. 39 does not divide by -9, but they can both divide by 3. So we could at least simplify this to 13 over -3. And that means our answer here would be a solution point of 4/9 for x and -13/3 for y. And that would be your final solution to this system.